Welcome back to my YouTube channel, guys. Today, we will be talking about Mathematics 7, Quarter 1, Week 5. Competency. Performs operations on rational numbers. Objectives. Number 1. Analyze each rule in performing operations on rational numbers. Number 2. Perform the operations indicated on rational numbers. Number 3. Display focus in analyzing the rules on operations of rational numbers. And the topic to be discussed is operations on rational numbers. So the first thing that we should know is what is a rational number. So rational numbers are all numbers that can be expressed in the form of A over B, where A and B are integers. So B also should not be equal to 0. Now, let's have some examples of rational numbers. Rational numbers can be counting or natural numbers. So what are the examples of counting or natural numbers? So when we count objects or things, we always start it with 1. So 1, 2, 3, 4, 5. So the first number for counting numbers is 1, followed by 2, 3, 4, 5, and so on and so forth. Now, the next example of rational numbers is whole numbers. So what are whole numbers? These are counting numbers that starts with 0. So whole numbers are counting numbers that starts with 0. So 0 is the first whole number, followed by 1, 2, 3, 4, 5, and so on and so forth. So the difference between counting numbers and whole numbers is just 0. For the counting numbers, there's no 0, while whole numbers starts with 0. Next example is integers. So we know integers can be positive or negative. So from this example, from the whole numbers 0, 1, 2, 3, 4, 5, starting from 1, 2, 3, 4, and so on and so forth, these are called positive integers. And left of 0, we can have negative 1, negative 2, negative 3, negative 4, negative 5, and so on and so forth. These are called the negative integers. 0 is just a neutral number. So the integers are the negative integers and the positive integers with 0. So the difference between whole numbers and integers are the negative integers. Next is fractions and or decimals. So the fraction or the decimals. So for the fractions and decimals, in between these integers, there are numbers. For example, between 0 to 1, we have 1/2. between 1 to 2, we have 1 and 1/2. Or that's 3 halves. Next, between 0 and -1, we have -3/4. These fractions can also be rewritten into decimals. So for example, 1/2 is just equal to 0.5. So how did I get 0.5? I divide 1 with 2. 1 divided by 2. Next, for 3 halves, that's 3 divided by 2, that's equal to 1.5. How about -3/4? -3 divided by 4, that's -0.75. So, these are the examples of rational numbers. Again, counting numbers which starts with 1, 2, 3, and so on and so forth. Whole numbers which starts with 0 and followed by counting numbers. And for the integers, these are whole numbers with negative integers. For fractions and decimals, these are numbers that can be found in between integers. So for example, 1/2 or 1/2, that can be found in between 0 and 1. So in decimal, 1/2 is equal to 0.5. While 3/2 can be found in between 1 and 2. That's 1 and 1/2 in mixed number, and for improper fraction, that's 3/2. If we convert that one into decimal, 3 divided by 2 is equal to 1.5. Next example, we have -3/4. -3/4 can be found between 0 and -1. -3/4 can be converted into decimal, and that is equal to -0.75. How did we do that one? -3 divided by 4. So next one is the operations with rational numbers. So there are 4 major operations. We have addition, subtraction, multiplication, and division. So here, I'll be showing you on how to add, subtract, multiply, and divide with rational numbers, specifically with fractions. So we focus here in this video with fractions, which is under rational numbers. How about for integers, whole numbers, counting numbers? That's been discussed in the previous video tutorial, specifically on Math 7, Quarter 1, Week 3. So now, let's focus first in addition and subtraction of rational numbers, specifically in fractions. So, adding and subtracting rational numbers. When combining rational numbers, turn the rational numbers into similar fractions using their least common denominator. So, we first made sure that the denominators are the same. So, through looking for the least common denominator. Next, we copy the denominator and put the sign of each fraction on its numerator, and then we add or subtract the numerator, then simplify. For example, we have 2/13 minus 2/13. I mean 3/13. So First, look for the denominator. Are they the same? If they are the same, then they are similar fractions. So, just copy the denominator. Next, copy the numerators. That's 2 and 3, and write the operation, which is subtraction. So, 2 minus 3 for the numerator. Next, 2 minus 3, that's negative 1 over, copy the denominator, 13. So here, we got the correct answer, negative 1 over 13. Example number 2. How about if they don't have the same denominators? Example, we have 4, that's 1/4, plus 2 over 6. Here, the denominator in the first fraction is 4, while in the second fraction we have 6. Are they the same? Are the denominators the same? No. So these fractions are dissimilar. So if they are not similar, we should make these fractions similar fractions. So how to do that one? First, 4 and 6 should be written. Now, look for the least common denominator, a least common multiple of 4 and 6. So the least common multiple of 4 and 6 will be solved using the listing method. So multiples of 4, we have 4, 8, 12. How about for 6? We have 6, 12, 18, and so on and so forth. Now, the common factors of 4 and 6 is, or the least common multiple of 4 and 6 is 12. So we will write 12 as the new denominator. Now for the new numerators. So first, 1/4 will be changed in a different fraction. So how to do that one? First, divide the new denominator with the old denominator. 12 divided by 4 is 3. The product will be multiplied to the numerator. So 3 times 1 is 3. Next, copy the operation, addition. Next, 12 divided by 6 is 2. The product will be multiplied to the numerator. So, the product is 2. 2 times 2 is 4. Again. So, how did I get 3 and 4? First, I get 3 using this method. Divide the new denominator with the old denominator. So, 12 divided by 4 is 3. 3 times 1 is 3. For 4, that's 12 divided by 6 is 2. Multiply that one with the numerator, which is 2. So 2 times 2 is 4. For the numerator, do the operation. 3 plus 4 is 7. While for the denominator, that's 12. So the final answer is 7 over 12. There is a shortcut method or a different method in solving or adding and subtracting rational numbers wherein the fractions are dissimilar. So if ever you have denominators that are not the same, you can use this method. So for example, we will solve 1/4 plus 2 over 6 with or using the shortcut method. So first thing is do cross multiplication for the numerators, and for the denominators or for the new denominator, you will just multiply them. So for the denominator, multiply the denominators. 4 times 6 is 24. For the new numerator of 1/4, you multiply 1 with 6. So that's cross multiplication with the other fraction. So 1 times 6 is 6. Copy the operation. Next, for the new numerator of this fraction, you multiply the old numerator with the denominator of the other fraction. So 2 times 4 is 8. Again, how did I get 6 plus 8 over 24? First, the new denominator is solved by multiplying the old denominators. So 4 times 6 is 24. Next, how did I get 6? I cross multiply 1, the numerator, with the denominator of the other fraction. So 1 times 6 is 6. Next, how did I get 8? The numerator multiplied to the other denominator of the fraction. So 2 times 4 is 8. Perform the operation of the numerator. 6 plus 8 is 14. Copy the denominator 24. Now, make sure that the fraction is in the least form or it can't be reduced. So 14 over 24 can still be reduced because they have a common factor that is equal to 2. So 14 and 24 has the common factor 2. So we reduce this fraction and the new answer is equal to 14 divided by 2 is 7, while 24 divided by 2 is 12. So if you have some question, how did I get 2? 14 and 24 can be factored out using this one. Look for the GCF, greatest common factor. Factors of 14 is 7 times 2. 7 can't be factored out, so that's just 7 over 2. How about 24? Factors can be 2 and 12. And 12 can be factored out to 3 and 4. 4 can be factored out with 2 times 2. Now, what is the common factor or the greatest common factor between factors of 14 and factors of 24? So we have 7, while on 24 we can't see a factor that is 7. So let's go to the next factor, which is 2. We have 2 under 14, while for 24, we have also 2 on the factors of 24. So the common factor between 14 and 24 is 2. The greatest common factor between 14 and 24 is 2. Let's have more examples in adding and subtracting dissimilar fractions. So, example number 3. We have 2 over 5 plus 2/3. So, let's use the shortcut method using cross multiplication and multiplying the denominators. So, for the new denominator, multiply 5 times 3, that's 15. Again, multiply the denominators, 5 times 3, that's 15. Next, for the new numerators, cross multiply them. So 2 will be multiplied to 3, that's 6. Copy the operation. 2 times 5, that's equal to 10. 6 plus 10 is 16. And copy the denominator, 15. So the final answer is equal to 16 over 15. Let's have the next example. We have 2 over 20 plus 2 over 5. Still these fractions are dissimilar because the denominators are not the same. Even though the numerators are the same, they are not similar fractions because the denominators are not the same. So, dissimilar fractions. Let's use the shortcut method again. Multiply the denominators. 20 times 5 is equal to 100. Next, for the new numerators, do cross multiplication. 2 times 5 is 10. While 20 times 2 is 40. Copy the operation, addition. 10 plus 40 is 50. Divided by the new denominator. Now, 50 over 100 can be simplified. And their common factor, 50 and 100 has a common factor of 50. So, how did I get 50? So again, let's do this one. So 50 had the factors 50 times 1, while 100 also have 50 times 2. Now the greatest common factor between them is 50. So we divide them with 50 over 50. So 50 divided by 50, that's equal to 1. 100 divided by 50, that's equal to 2. Now the final answer is equal to 1/2. Now the next operations are multiplication and division. So multiplying and dividing rational numbers. So there are two major rules in science when we multiply and divide rational numbers or integers. So these are: if the signs are the same, then the result is positive. So, for example, negative times negative, that's equal to positive number. While positive times positive, that is equal to a positive number also. Next, if the signs are not the same, then the result is negative. So if the signs are not the same, then the result is negative. Example, positive times negative, that's equal to a negative answer. So they are not the same, so the answer is negative. How about negative times positive? Still the answer is negative. So that's the same thing with dividing. If the signs are positive, then the result is positive also. Again, that's the same thing when dividing. So for example, negative divided by negative, that's equal to positive number. And for positive divided by positive, that's also equal to a positive number. And if the signs are not the same, then the result is negative. Example, positive divided by negative is negative, while negative divided by positive is also a negative answer. So please remember these two major rules in multiplying and dividing integers or rational numbers. Now let's have examples in multiplying rational numbers. So example number 1. Two-thirds times 3/1. So in multiplying rational numbers, multiply the numerators by the numerator, while multiply the denominator by its denominators. So 2 times 3 is 6, while the denominator is 3 times 1, and that's equal to 3. Simplify the answer, and the result is equal to 2. 6 divided by 3 is 2. Let's have another example. We have 2/2 times negative 3/5 times 1/9. So there are 3 fractions. So the same thing. Multiply the numerators and multiply the denominators. 2 times negative 3, that's negative 6. Negative 6 times 1, that's negative 6. Again, 2 times negative 3, that's negative 6. Why negative 6? Because the signs are not the same. So if they are not the same, the answer is negative. So negative 6 times 1 is negative 6 over 2 times 5 is 10 times 9, that's 90. And negative 6/90 can be simplified. So they have a common factor that is equal to that's equal to positive 6. So we can write negative 6 and 90. Negative 6 can have the following factors: 6 times negative 1, while 90 can have the following factors: 6 times 15. So they have a common factor, 6. So 6/6. Negative 6 divided by 6 The signs are not the same, so the answer is a negative 1. So 6 divided by 6 is 1. So we will have a result that is negative 1. Next, 90 divided by 6, that's 15. So the final answer is equal to negative 1 over 15. The third example will be dividing rational numbers. So let's have this example. 1 over 5 divided by 2/3. So there is a major rule in dividing rational numbers, specifically fractions. When you divide fractions with another fraction, you will do reciprocal first. So what is reciprocal? First, do the reciprocal of the divisor. So, write again 1/5. The reciprocal of 2 over 3 is 3 over 2. So, reciprocal of 2/3, you will just interchange their places. The denominator will become the numerator and the numerator will become the denominator. So, 2/3, reciprocal of that one is 3 over 2. Now, change the division sign, that will become a multiplication sign. So, we will proceed now to multiplication of rational numbers. Again, first, when you have fractions that is being divided by another fraction, or you are dividing rational numbers, the first thing that you should do is do the reciprocal of the divisor or the second fraction. So reciprocal of 2/3 is 3 over 2. And then change division to multiplication. And then proceed to multiplying rational numbers. 1 times 3 is 3. 5 times 2 is 10. Numerator times numerator, denominator times denominator. Let's have another example. We have negative 7 over 15 divided by 3. So, the divisor is a whole number. Still, we can do reciprocal. So, copy first the first fraction. Next, reciprocal of 3 is 1/3. How did I get 1/3? We all know that all whole numbers are divided by 1 or are over than 1. So for example, 1, 2, 3, 4, 5. These whole numbers has an imaginary are divided by 1. So 1 divided by 1, while 2 divided by 1 is 2, while 3 is being divided by 1, that is still equal to 3, 4 over 1, 5 over 1. So, even though we divided them with 1, still, they will not be changed. So, 1 divided by 1 is just equal to 1. 2 divided by 1 is equal to 2. 3 divided by 1 is just equal to 3. 4 divided by 1 is just equal to 4. 5 divided by 1 is just equal to 5. So, for 3, that's 3 over 1. Reciprocal of that one is 1/3. After doing the reciprocal, change division to multiplication. And then proceed. numerator times numerator. So negative 7 times 1 is negative 7. For the denominator, so you will not use this sign already because that is being used by the numerator. So we'll just have 15. 15 times 3 is equal to 45. And we can have the final answer as negative 7 over 45. So that's it for Math 7 Quarter 1 Week 5. I hope you've learned something in this video and see you on my next video tutorial.